Good morning. Let us see today the determination of degree of dissociation, dissociation constant and pH of weak acid or weak base from conductance measurement. That is application of conductance measurements to the determination of alpha, Ka and pH. Using Ostwald's dilution law, the degree of dissociation can be calculated. Using Ostwald's dilution law, we have seen in previous video, the degree of dissociation is calculated. For example, acetic acid is a weak acid. It is partially dissociated. It is not completely dissociated. It is partially ionized. Similarly, for ammonium weak base, you can also write ammonium hydroxide, ammonia plus OH minus. Okay. So at T equal to 0, the concentration of acetic acid taken is C moles per liter. This is 0 at T equal to 0 because there is no dissociation. At equilibrium, after some time, there will be dissociation and there will be equilibrium, dynamic equilibrium between the acid and its ions. Okay. Therefore, at equilibrium, the alpha is the degree of dissociation. That is the fraction of the electron. What is alpha? It is defined as the fraction of the electrolyte dissociated, fraction of the acid dissociated or ionized for one mole. Therefore, for C mole, C into alpha. That is alpha is for 1 mole. Therefore, C alpha. Therefore, here 1 minus alpha, what is dissociated, and the concentration C. Therefore, by applying the law of mass action, Ka equal to concentration of the product ions divided by concentration of the reactant, C alpha whole square. Therefore, C 1 minus alpha. Ka equal to C get cancelled. C alpha square 1 minus alpha. 1 minus alpha, actually the degree of dissociation in some of the cases only, remember, is very small, 0.00. Therefore, 1 minus alpha is taken as 1. For example, problem I have shown, the degree of dissociation is larger than this formula is used. Okay, and alpha, if it is 1, then alpha equal to Ka by C. This is 1. Therefore, alpha is equal to square root of Ka by C. If alpha is very negligible, okay, remember, then concentration of H plus ion equal to C alpha, alpha C or C alpha, concentration. From the concentration of H plus ion, we can calculate the pH of the solution, pH of the weak acid. What is the pH for that concentration? For the concentration C. Okay, at different concentration, the concentration of H plus will vary. And therefore, using the Ostwald dilution law, we can calculate the pH, concentration of H plus ion, dissociation constant of weak acid or weak electrolyte, and how alpha is determined. Now, from conductance measurements, the value of alpha, the degree of dissociation can be calculated, can be experimentally found out. How it is the procedure? Let us see the method. Let us see the procedure. How there are 3 simple steps involved in it. 1, prepare 0 point particular concentration of weak acid or weak base. For example, here prepare 0.01 molar acetic acid or any weak acid, weak base 0.02 or any concentration. Okay, and take the solution in the beaker. Take the weak acid or weak electrolyte solution in the beaker and place the conductivity cell. Place the conductivity cell, connect to the conductivity bridge. Measure the conductance of the above solution. Measure the conductance. Second step. And you have measured the conductance lambda m. Okay, this is actually your lambda m. And how lambda infinity, the molar conductance in infinite dilution or in limiting concentration, can be calculated using Kohlraas law. Okay, using Kohlraas law, lambda infinity m. Please watch the Kohlraas law video and how the molar conductance at infinite dilution is calculated. Okay, so let us now see few problems asked in IIT-JEE. So that you will be familiar with the units. The molar conductance of 0.012 mole per liter, 1 decimeter cube equal to 1 liter. Remember, of course, solution of chloroacetic acid is 100 per mole inverse. Centimeters per mole inverse is Siemens or mole inverse. calculate the degree of dissociation, pKa and H+ion concentration. You are given lambda infinity for weak electrolyte, for weak acid. For strong electrolyte, it can be experimentally determined. For weak electrolyte only calculated using Kohlraasch law. Okay. So using Kohlraasch law, it is given here and measured. For this concentration, the molar conductance is 100 per ohm centimeters per mole inverse divided by 400, therefore 0.25. That is the fraction of electrolyte that is dissociated or ionized. Using now the concentration of H plus can be calculated by using this formula alpha C. Alpha is 0.25 we have calculated and the concentration is given 0.012, therefore 3 into 10 to the minus 3 moles per liter or moles. This is moles per liter. We can also write more M, capital M. The degree of dissociation, from degree of dissociation, the Ka, the dissociation constant of weak acid or weak electrolyte can be calculated. Dissociation constant of weak acid equal to C alpha square 1 minus alpha. The formula we have derived earlier. You substitute C value, alpha value, and you will get 10 to the minus 3. In this case, alpha value is significant. It is not negligible. The alpha value is not negligible. If it is negligible, then 1 minus this is 1. Okay. So remember, alpha value is sometimes negligible if it is very less. Then pKa, similar to pH, negative logarithm to the base 10 H plus ion concentration, pKa, therefore Ka we have calculated, therefore minus log to the base 10, therefore minus 3, therefore 3. Okay, now let us see another problem. The solubility product of calcium fluoride is given 3.2 into 10 to the minus 12. Calculate the solubility of calcium fluoride in moles per kilogram of water. 1 kg of water equal to 1 liter of water. Moles per liter, 1 kg, because the density of water is equal to 1. Okay, calcium fluoride is a weak electrolyte or sparingly soluble salt to give calcium ion and fluoride ion, and S is the solubility. If S is the solubility of the calcium fluoride, then S moles per liter, S moles per liter of calcium ion will be there, 2S moles of fluoride ion will be there. Using the formula Ks equal to S into 2S whole square, because 2S whole square 4S cube, therefore 4S cube, and S cube equal to Ks3 divided by 4. On substituting the value Ks3 by 4 and then taking cube root, you will get S equal to 2 into 10 to the minus 3 moles per liter. So there are several problems asked based on this. Please write down the formula so that it will be useful for your semester exam as well as competitive exam. Thank you for watching.